Hello, and this is the beginning of the video for chapter 9 vectors for the further maths course, year 12 for edexcel. So what I'm trying to do in this first section, just a bit of introduction of what vectors are, and this is how we've seen vectors in GCSE, and if you've seen these vectors in mechanics, this is how you see this. There's an arrow there, then the little name on the top, then vectors are represented by this small little name written in bold, or sometimes you put little sign under them. This is how the vectors are represented. Okay, now position vector is the first term which I would like you to know. This is how do you move from origin to the point you want to go to. So in this diagram, position vector of point A would be vector OA, and if you see, we move it one step to the right and two steps up. So if you have to write this, OA is a column vector, this will be 1, 2, and position vector of OB would be, I'm going to write closer to this over here, that's OA by the way. So OB is going to be 1, 2, 3, 4, 5 steps to the right and 1, 2, 3 to the top. So 1, 3, 5, 3, sorry. Okay, so then comes the IJ notation. This is the unit vector notation, people will use it. And how does that work? We say that unit vector is vector with magnitude 1. So in the x direction, the unit vector is I, in the j direction, sorry, in the y direction, it's j. Right, so unit vector notation for this will be this vector OA can be written as 1i plus 2j, and OB is 5i plus 3j. Okay, now if somebody asks you to find AB, vector AB, displacement of from point A to point B, guys, what it is simply, if you write this as vector A, vector B, it is just B minus A. So you can use position vectors in terms of column or in terms of IJ, and AB would be, if I do, this is B is OB, which is 5, 5, 3, take away 1, 2, so this is 4, 1, and we can see that as well. If I want to move from A to B, I want to go 1, 2, 3, 4 steps to the right and 1 up. This is what it is, or it is 4i plus 1j. Okay, this is all about the position vectors and column vectors and IJ notation. Right. Few more things which you need to know is the magnitude of the vector. This is just the number value. Obviously vectors, you know, have direction as well as the magnitude. Okay, so if I have to find magnitude of this vector OA, the magnitude, this is how we write this as modulus, which will be Pythagoras, this is 1 squared plus 2 squared square root, and magnitude of AB will be 4 squared plus 1 squared square root. Okay, similarly we can find the distance between the 2 points, that will be the magnitude of AB. So you want to do this between 2 points, just find the vectors and find the magnitude of that vector. Okay, with that information, we're going to be relating now a vector geometry to the normal coordinate geometry we've learned, and I'm going to start with writing equation of a line in vector notation. Alright, vector equation of a line, this is section 9.1. Okay, so what I'm going to try and do, I'm going to try and relate this to the normal coordinate geometry. If I ask you, in a two-dimensional coordinate geometry, this is a point which is, let's say, 0, C, and find equation of the line with the gradient m. Okay, there's no need to put this arrow in. So equation of this line is y equals mx plus c. Okay, this is the x-axis, this is the y-axis, where m is the gradient and y is the, so c is the y-intercept. The vector equation of a line, let's say there is a point A and there is a vector B, that means a direction B, and you're going to find equation of a line which passes through this fixed point and is parallel to that vector. Now guys, the direction is the equivalent to gradient there, and fixed point is equivalent to the y-intercept there. Okay, so the if O is the origin somewhere of the coordinate axis, so OA will be the vector A, position vector, and let's say R can be any moving point on to the line, so OR will be the vector R. Okay, so R would be equal to A, the fixed point, vector A, plus lambda B. B is the direction, and lambda is any scalar. Scalar means a number. So guys, B is the direction, gradient. Okay, that is a two term, and this is fixed point, which is a single term. They're just trying to relate this vector equation to this normal equation of a straight line in 2 dimensions. Okay, the next extension is now to find equation of a line which passes through 2 fixed points A and B. Let's start this again, guys. So we're going to be making the 2 position vectors. Let's call this A and this is B, so excuse my drawing. Okay, and now the direction is not given, so but we find the direction is, we want in this direction of AB. Okay, so AB is the direction, and what we learned from the introduction bit was AB equals B minus A. Okay, so this can be a fixed point, so the equation of the line would be R equals A plus the fixed point plus lambda, the scalar, then the direction B minus A. This is the second way of writing equation of a line, but this time it is equation of a line which passes through 2 points when the direction vector is not given. So we work out the direction vector ourselves, okay, which is B minus A. So let's go through some questions of exercise 9. First question: for the following pairs of vectors, find a vector equation of a straight line which passes through the point with the position vectors A and parallel to the vector B. So this is actually the first type, when you know the direction vector and you know the fixed point. Okay, so we're going to do one of these questions. Let's see if we do question part D here. Okay, you can try this yourself. Right, so this is the equation of that line, R equals A plus B, and you can write this in parametric form, which means you include the parameters and write as one column vector 2 minus 3 lambda, and then 0 plus 2 lambda and 4 plus lambda. So this will be the equation of that line AB. Okay, so we move on to the next question. So question 2 is the second type, when you're given with the 2 points P and Q and their position vectors. Okay, and you're going to find the vector equation of the straight line. Obviously we need to find the direction, so we'll be finding direct vector PQ because that'll be the direction there. Let's do part D of this as well. Right, so in this case the equation of the line will be R equals the fixed point, which is P, 3 minus 1 4 plus lambda times the direction, which is Q minus P, because we want to go in this direction PQ. Okay, Q minus P direction will be minus 2 minus 3 and 3 minus minus 1 and 1 minus 4. So we can make it neat and write the equation. That will be the equation of this line which passes through points P and Q in this case. So question 3 will be type 1. Find a vector equation of the line which is parallel to z-axis. Parallel to z-axis means what, guys? Its position vector or the direction vector is only z. It's got nothing in terms of x, not in terms of y. So direction vector could be only z, guys. X is 0, y is 0, and passes to the fixed point, this one. Okay, so you can write this equation. We'll work on the answer together. So the any line parallel to z-axis will have only z coordinates. So x will be 0, y will be 0, and z could be anything. Let's make just unit vector z, which is 1. So that's my direction vector, and this is my fixed point. So fixed point is 4 minus 3 8. So equation of line first type, it is 4 minus 3 8 plus lambda 0 0 1. That's equation of this line there. Next thing we will need to learn is how do we write Cartesian equation of a line in 3 dimensions, guys. Cartesian equation is lines in terms of x, y, and z. This is normal geometry we've been doing. So imagine we have we need to write equation of a line passing through fixed point a1, a2, a3 in 3 dimensions, and parallel to, that means I know the gradient vector, to a vector which is b, b1, b2, b3. This is vector A. Okay, so the equation, the vector equation would be r equals, we learned a plus lambda b. Okay, let's try see how do we change this into Cartesian. This is something which you need to memorize, which you need to know, which you need to learn very well. All right, in Cartesian form, I mean, where we say r is the position vector of a moving point on vector form, in Cartesian form the moving point is x, y, z. That's a general point, isn't it? So r equals a is a1 over a2 over a3 plus lambda b1, b2, b3. And guys, the equality of column vectors you know from GCSE. I'm going to equate the top bits. So x equals a1 plus lambda b1, and y equals a2 plus lambda b2, and z equals a3 plus lambda b3. I'm going to rearrange these 3 equations to write in a form which is standard form of 3-dimensional Cartesian equation of a point, of a line passing through 2 points, passing through a point and in one direction. Okay, so we rearrange these 3 equations right in this form, and you can see that all 3 of these fractions are equal to lambda. So we can write this conveniently as x minus a1 over b1 equals y minus a2 over b2 equals z minus a3 over b3 equals lambda. This is the Cartesian equation of a straight line in 3 dimensions. Okay, so question number 4 of exercise 9a, I'll ask you to write this. We'll show you in a minute. So right, look at question number 4. It says find a vector equation, which you can do. First find the direction vector, this minus this, then take a fixed point, then plus lambda direction b minus a. Then it asks you to write down the Cartesian equation of this form. So guys, you're going to do the same thing absolutely now. You found the direction vector already, so that's your b's, and you're going to take any of this point as a fixed point and write the equation of these lines. Okay, so can you see part question number 4a part 2? Let's do that together. You do that, write vector equation and the Cartesian equation, then mark with my answers. All right, the vector equation, we need the direction vector. So direction vector is position vector of the second point, take away for position vector of the first one. Remember, that's b minus a. We discussed this last. So direction vector would be 7 minus minus 3 is 10, 2 minus 5 is minus 3, and 2 minus 0 is 0. That's your direction vector. So equation is r equals fixed point, the first one, minus 3 5 0 plus lambda times direction vector 10 3 10 minus 3 0. Okay, to write the Cartesian equation now, we got the equation there. To write the Cartesian equation for the second part of this question, or part b, it is, okay guys, fixed point is that one. So x minus minus 3 over the direction vector 10 equals y minus 5 over direction vector minus 3 equals z minus 0 of the fixed point over the direction vector. That comes out as 0 as well. Okay, did it come out as 0? That should be 2, isn't it? Yeah, that should be 2. So over 2, this is the Cartesian equation. Obviously that will be equal to the scalar vector, which you don't need to show for the equations. This is the Cartesian equation of a line passing through these 2 points, and this is the vector equation of the line passing through these 2 points. Okay, so we move on to the next few questions now. All right, I'm going to now talk about few questions. I might not be able to do this, okay, because video is getting longer for the first exercise. So it says the points this lie on the line L. Find the values of P and Q given that equation of line L is this. So I'll just tell you what do we do, guys. What we're going to do, what's the equation of this line in parametric form? Like I said, in one vector, 2 plus 1 lambda minus 3 minus 4 lambda and 1 minus 9 lambda. I equate that to 1 P and Q because the point lies on the line. It should satisfy the equation. From the first part, 2 plus lambda equals 1 gives you the value of lambda there. Lambda is a parameter, isn't it? Okay. And then find the values of P and Q there, guys. Let me explain to you what lambda stands for. This is the value of the lambda. Actually, if you pick a different value of the lambda for a vector equation, that means you get a different point on that line. Okay, this is what lambda is. With on the same direction vector, gives you a different point on that line. Right, so work that out. Let's say you do question number 5 part A, then we check the answer with mine. Okay, question number 6 now. Similarly, question number 6, have a look. It says line has this equation, line L2 has this equation. Show that line L1 and L2 are parallels. So lines will be parallel if the direction vectors are same or multiples of each other. So guys, equate this to lambda and find the direction vector, which is 2 minus 4, 8, and this is minus 1, 2, 4. If you times this by minus 2, that will give you these answers. So direction vectors are multiples of each other, so lines are parallel. Okay, show that the line L2 with the equation this, L1 with the equation this is parallel to line which passes through this point. So write down equation of this line which passes, just the direction of this, okay? Just the direction of this AB, and find the direction vector of this, and you'll see if they're multiples of each other, they'll be parallel. Show the point this is a collinear. Guys, what do? Similar, this is GCSE type question. Find the direction of AB, find the direction of BC. If direction vectors are same or multiples, and because they share a point, they can't be parallel AB and BC, so that means they're collinear. Okay, show that the points with the position vector this do not lie on the same straight line. Same thing, guys, you talk about the directions of these 2 points, the direction of these 2 points. If directions are not multiples of each other, they don't lie in the same straight line. Okay, so many questions. Question number 10, these 3 points and AB are constants. Okay, what do the collinear? So collinear, guys, direction again. So find the line this. Okay, I'm going to ask you to have a look at these questions again. If I see anything which is tricky, I'll try and explain that to you, guys. That concludes the first section. This is up to section exercise 9A of vectors, introduction and exercise 9A. I'll bring you second video soon.